recording. Okay, there we go. Okay, so let's get things started. So yesterday we saw all four methods of solving quadratic equations. They were factoring, right? Zero factor property, and then square root property, and then completing the squares and the quadratic formula. Okay, so now today we will apply those methods to three applications. Okay, so now the first application is factoring cubes. And for factoring cubes, there are two formulas. Okay, and here are the two formulas which I gave you. And the thing is, most people cannot memorize these two formulas at all. And you can see why. It just looks complicated. Okay, so there are two cases: the sum of cubes and then the difference of cubes. Okay, and the right hand side looks ugly, but if you look at closely, so ignore all the signs like pluses and minuses. Okay, so when you ignore all the signs, notice that all of these have the same exact bone structures. Okay, do you see that? Because the first factor has a and b, okay, and the second factor has a square, ab, and b square. Okay, so they both have the exact same bone structures. The difference is the signs. Okay, so how do you tell which sign goes where? So that's why I gave this soap. Okay, so apparently it's the time to be clean these days. Okay, but that's not the point of this soap. But this soap means something. Okay, so S stands for the same sign. Okay, so the same sign. And then O means opposite. Okay, opposite signs. And then AP goes together. Okay, so AP means always plus. Always plus. Okay. And hopefully you can see why this makes sense in terms of the signs. Okay, so first one, we have the sum. Okay, and then the first blank, we just keep the same sign. Okay, so we just put plus sign. And for the second slot, we have to flip it because it says opposite. Okay, so here's the opposite sign minus. And then the last one, always plus. Okay, so we have always plus here. And then similarly, if we start with the subtraction sign at the beginning, okay, then we keep the same sign, which we do. Okay, and then we flip it, which means plus, and then the last one is always plus. Okay, so there we go. Okay, so as long as you memorize these exact same bone structures, A, B, A square, AB, and B square, and then fill in the signs according to the soap, everything will be going in the right direction. Okay, so why are we talking about the cubes in terms of, or even though we are talking about quadratic equations? So number 5, solve x cubed minus 27 is equal to 0. Okay, so here, let's try to use one of the two formulas. Okay, so here, where we start off is, let's try to see if we can factor this left-hand side, x cubed minus 27. Okay, now, which formula between these two should we use? It's this one, right? Do you see why? Because the reason is simple. We have subtraction, okay, in between x cubed and 27. So we have to use the second one, okay? And if you look at the second one, what does it say? We have to have a cubed and b cubed, right? Okay, so what does that mean? Well, we have a cubed form here, okay, that is x cubed, right? Okay, and now the question is 27 something cubed? And the answer is, yes, it is, right? Okay, 27 is what cubed?
3.
3, right? Okay, so it's x cubed minus 3 cubed. Okay, so what do you notice here? In place of a, we have x. Okay, and in place of b, we have 3, right? That big 3 here, like not this little 3. Okay, so you can plug in x and 3 into the right-hand side here. Okay, so what do you notice? So it's x minus 3. Okay. Okay, so again, remember we keep the same sign. Okay, and then the second factor says, so x squared, okay, which is a squared, and then it's ab, so that's x3. Okay, and then b squared, which is 3 squared. Okay, and in order to fill in the blanks in terms of the sign, okay, so it's the same sign, and then we have to opposite it, so that means it's plus, and then always plus, so that's also plus here. Okay, and notice that we can clean things up inside the second factor here. Okay, so we can rewrite it as, so x3, that's same thing as 3x, right? And then 3 squared is 9. Okay, so we have x minus 3 times x squared plus 3x plus 9. Okay, so now you may want to factor this second factor further. But what do you notice here? So if you want to factor this, you need to look for the two numbers whose sum is 3, and then the product is 9, right? Okay, 1 times 9, right? And what do you notice? Are there such two numbers? No, right? So what does that mean? This one, you cannot factor. Okay, so that's the kind of convenient thing about this factoring cubes. For this long factor, no matter what you try, you cannot factor. Okay? Anyways, so we have 0 on the right-hand side, so we set it equal to 0. Okay? So now, from the class yesterday, what did we study? So when you multiply two factors, namely these two, and we multiply them and we get 0. Okay, so now what does that imply? That implies one of them has to be a 0, right? That's the 0 factor property. Okay, so what does that mean? The first factor has to be a 0, or the second factor has to be a 0, right? Okay, I mean, that's precisely the 0 factor property, although the difference between yesterday's class and this problem is the second factor looks ugly. Okay, that's all. Okay, so now the first equation is really easy, right? This x is equal to 3. Okay, so that's simple. And now what about this one? Okay, so we saw that it can be factored, and this is a quadratic equation. So what's pretty much the only way to solve? So the only way to solve is what? I guess the most convenient way. It's the quadratic formula, right? Okay. And now, remember, for the quadratic formula, what do you have to do? Identify A, B, and C, right? Okay. So here, what is your A and B and C?
Is x squared A?
A and B and C are numbers, not having any x. So A is equal to what?
1.
1. And what is B?
3.
3. And C?
And
9.
9, right? Yes. Okay. And now, I'm not gonna revisit to the quadratic formula, but hopefully you have already memorized it, or you get to memorize it eventually. Okay. So x is equal to, so it's negative b, right? Okay. So what does that mean? Negative 3. And then remember we have plus minus sign, right? Okay. And then we have square root. And now what goes inside the square root? B squared minus 4AC, right? Okay, so what does that mean? 3 squared minus 4 times 1 times 9. And everything over 2A, right? Or 2 times 1. Okay? And now, simplify, especially the thing under the square root. Okay? So now, 3 squared is 9. And then minus, that's 36, right? So 9 minus 36, what's that? Negative 27? Okay, and everything over 2, right? Okay, and now we need to further simplify, okay, especially this one, right? So first what do we do? So here we see the negative sign or negative number under the square root. So what does that mean? We can do this, right? Okay, so we have negative 3 plus minus square root of 27i and everything over 2. And now, can you further simplify square root of 27? And the answer is yes, right? Okay. So how do you simplify? That's 9 and 3 and 3 and 3, right? Okay. So what do we pull out? The 3, right? Okay, so we pull out 3 and that 3 is the leftover, right? Okay, so we have what? Negative 3 plus minus 3 square root of 3i all over 2, right?
Can you zoom out?
I can't see that side of your paper.
Oh, I'm sorry. Better?
Yes.
Yes, sir.
Okay. Okay, so we have negative 3 plus minus 3 square root of 3i all over 2. Okay, so we are done, right? So that's the answer, right? Yeah? Yeah?
No.
No? Okay, yeah, right? Because if I ask right 3 times or so, then you know there's something wrong. Okay, so are we forgetting something? Okay, so this was from which equation? That equation, right? Okay, but was that the only thing from our original cubic equation, or was there something else? I think this one. Okay, so we shouldn't forget about this, right? Okay, so what's the answer then? It's this and 3, right?
Yeah.
Okay, so how many numbers or how many answers did we get?
2.
2? No, look closely. It looks like it's 2, but it's not 2.
It's 3 because of the plus and minus sign.
Does everyone see that? Okay, so it
Yes.
looks like it's 2, but it's not, because plus minus means we have 2 solutions, okay, and then we have 3 as well, so there are 3 solutions, okay. So that was first application, okay, and now application number 2. Solve for a specified variable. Okay, so hopefully all of you have seen this scheme before. Okay, so basically, what's your goal? There will be multiple letters. Okay, in this case, there will be a number, like there will be numbers, but on top of that, there will be lots of letters, and you have to add, subtract, multiply, divide letters or numbers until you isolate that target variable by itself on one side. Okay, hopefully you remember that. And one of my students in the spring semester said, because of this pandemic, her son loves to use the word quarantine the variable by itself on one side. Okay, so yeah, it makes sense, right? So anyways, quarantine the variable or isolate the variable, no matter what you want to choose, Well, apply that to this problem. Solve v equals 1/3 pi r squared h for r. Okay, so now here, what's your goal here? Isolate r, right? Okay, by itself. Okay, so where is r? It's right there. Okay, so we have to isolate r by itself. So what do we have to do first? So what do we have to do first? Any suggestion?
We can multiply both sides by 3 to clear out the fraction.
Right, so first remove the fraction, and the only way to do it is multiply by the LCD, which is 3, okay? So times 3 to both, okay? So times 3 like this. So what does that mean? 3's cancel here, and we have 3v is equal to pi r squared h, okay? And again, here is the target variable. And now step number 2, what can we do to get r by itself?
Square root of pi h.
We are not taking the square root yet, but we need to do
Okay.
something before we take the square root.
Divide both sides by pi.
Divide both sides by pi. Now, can you divide something more?
And h.
H as well, yes. Okay, so divide both by h, or pi h, okay? So what does that mean? Over pi h right here. Okay, so that means pi's cancel, h is cancel, right? Okay, so we have 3v over pi h is equal to r squared. Okay, and then we can take the square root. Okay, so square root. So what do we get? R is equal to square root of 3v over pi h, right? Okay, so that's the answer, right? That's the answer, right? Are you sure?
I don't know.
You don't know?
No.
Okay. Are we forgetting something? Square root. Are we forgetting something?
You can't have a denominator in the square root, right?
Well, we could. That's fine. That's fine because like square root of like say 3 over 2, that's okay, right? But are we missing something?
Plus or minus.
Thank you. Yeah, what did I say yesterday? People will forget to put plus minus sign, so I will end up begging students, right? There we go. Okay, 4th time. Okay, 4th time. Yeah, in less
Okay,
than 2
I'm so.
Yes?
I know I missed the lecture yesterday. I'm still trying to catch up, but can you explain why the plus and minus?
So think of this problem here, x squared equals 4, okay? So when you take the square root, x could be 2, but also it can be -2 because
-2.
when you square -2, you get also 4, okay? So you need plus minus. Okay?
Got it. Thank you.
This is part of the square root property, which you still need to catch up from yesterday's class.
Yes, sir, but that makes sense. Thank you.
Yeah, you're welcome. Okay, so now application number 3, the discriminant. Okay, now again, be careful. This is not the discrimination. Okay, it's a discriminant. There's no politics here. Okay, it's discriminant, not discrimination. Okay, now the letter used for the discriminant is capital letter D. Okay, now the discriminant is equal to b squared minus 4ac. Okay. Have we seen this b squared minus 4ac before? Yes. Where? Inside the quadratic formula, right? Now, where in particular in the quadratic formula? Under the square root from the quadratic formula, right? Okay, it's under the square root. So we have, like negative b plus minus square root of, now we know the notation, d over 2a, right? Okay, instead of b squared minus 4ac. Okay, so it's the discriminant, which is the thing under the square root. Okay, so now, why do we need to study this discriminant? Because, can I go to the next page? Okay, so now, here is the fact about the relationship between the discriminant d and the number of solutions, okay? And there are three cases. Number one, positive discriminant. Number two, zero discriminant. And number three, negative discriminant, okay? And now the positive discriminant produces two subcases, positive discriminant and its perfect square. So what does that mean? You have something like negative 3 plus or minus square root of, let's see, 16 over 2. Okay, so something like this. So the discriminant, the number under the square root is positive and it's the perfect square. For example, 16. Okay, now in this case, what do? You can remove the square root, right? Okay, so you have negative 3 plus minus 4 over 2, for example. And what does this imply? It's negative 3 plus 4 all over 2, which means it's 1/2, right? Or negative 3 minus 4 over 2, so that's what? Negative 7 over 2, right? Okay, so what do you deduce here? We have two solutions which are distinct, but these two are so-called rational numbers. Have you heard about rational numbers before? Okay, rational numbers, which technically means fractions. Okay, so we have two distinct rational answers. Okay, so again, rational simply means either whole number or fractions. Okay, it could be decimals as well, but just to make things simple, fractions is the most popular example of a rational number. Now, second case, positive discriminant, but it's not a perfect square. So what does that mean? Something like this. Okay, now in this case, what do? So now this square root cannot be removed, right? Okay, the best thing that you can do is simplify, like when you have square root of 8, for example, but this is not a whole number, no matter what. Okay, and in this case, what do you have? You still have two numbers, plus and minus, like because of plus and minus, but this time it's not a rational number because we cannot remove the square root. So what does that mean? It's irrational. Okay, so it's two distinct irrational numbers. Okay, so the difference between case 1 and case 2 is rational and irrational. Okay, now third case, zero discriminant. Okay, so now the zero discriminant. So what does that mean? So zero discriminant means we have, I'm running out of space. Okay, so we have something like, negative 3 plus minus square root of 0 all over 2. Okay, so we have something like this. Now, in this case, what does that mean? Square root of 0 is 0, right? Okay, so we have negative 3 plus minus 0 over 2, but adding and subtracting 0 to anything doesn't change the number itself, right? Okay, so here what do you get? Negative 3/2. So how many numbers do you get? Just one, right? Okay, so this time you have 1 repeating, but you don't have to write this repeating part, rational number or rational solution. Okay, again, we have rational instead of irrational because there's no square root. Okay, and now negative discriminant. So what does that mean? Here we have like -3 plus minus square root of, say, square root of -2 all over 2. Okay, then what does that mean? Whenever we have the negative number under the square root, we have to pull the negative sign out and change that into an I, right? Okay, so what kind of numbers do you get? This time there's no real number, right? But instead there is a complex number, okay? But because of plus minus, there are two numbers, okay? So there are two distinct complex solutions, okay? So in short, case 1, 2, and 3 produces real numbers. That is the only case where it produces complex number, okay? And this fact like looks hard, but like I said, as long as you consider these 4 specific examples, it's not that hard, okay? So let's look at number 7. Find the discriminant of each, and then determine the types of solutions. Okay, so now notice that the problem does not ask you to solve each equation, but rather you have to find the discriminant, okay? And remember, the discriminant was b squared minus 4ac. Okay, so what do you have to do to find the discriminant? Identify a, b, and c, right? Same thing as when we were using quadratic formula, okay? So, number 1, let's find a, b, and c, okay? So, here, a is what? 4, right? And b is -12, and c is equal to 9. You see that?
Yes,
Okay.
sir.
Yeah. So now, the formula for the discriminant is b squared, so that's -12 squared, minus 4 times a times c. Okay, so 4 times 4 times 9. Okay, now, what is -12 squared? What's that equal to?
144.
144, yes. And now, what is 4 times 4 times 9?
144.
Also 144, yeah, right? So what's the discriminant? 0. Okay, so now what does that mean? We will have 0 under the square root from the quadratic formula. So what does that mean? That plus minus sign won't matter, right? So what kind of solutions do we have? Just one, right?
0.
Well, it's not a 0.
Oh, 1. Yeah.
Yeah, so we have one solution, right? So to be more precise, what does that mean? It's one repeating rational, right?
Yes.
Okay, so in other words, there is one solution. We don't know what that is, but for sure there is only one solution, okay? But it's a rational number, which means there's no square root. Okay? And now, part B, 3x squared plus x is equal to -5. Okay, so now here, what is your A?
3.
Okay, what is your B?
1.
1.
And what is your C?
Negative.
+5.
Okay, +5 or -5. Okay, so now we have some dispute, right? So is it +5 or -5?
It's +5.
It's +5, yes. Do you see why? Okay. So what's the difference between this part B and this A? The right-hand side is not a 0. Okay, and remember, that contradicts the setup of the quadratic formula, okay, because the quadratic formula assumes we have 0 on one side. So before you identify A, B, and C, what do you have to do? Make one side equal to 0. So plus 5, okay? So 3x squared plus x plus 5 equal to 0. And then you can identify A, B, and C, okay? So, and then identify A, B, and C. So A is equal to 3, B is 1, and C is 5. So the discriminant is equal to B squared minus 4AC. Okay, so now 1 squared is 1. And then 4 times 3 times 5 is what? 12 and 60? Is that right? Okay. So 1 minus 60 is what? Negative 59, right? Okay. So now the discriminant is negative. So what does that mean? We will have square root of negative 59 if we apply the quadratic formula, right? So that's a negative number. So what does that mean? We'll have to pull out an I, right? Okay, so what does that mean? There are two distinct complex solutions. Okay. And now, part C, 2x squared is 6x plus 7. Okay, so now here, what is your A?
2.
Okay, what is your B?
Negative 6.
Negative 6. Do you see why? Okay, again, here, we don't have 0 on one side. So we have two options. Move this thing to here or these two things to here. Now, what is better? Move 6x plus 7 to the left-hand side is better, right? Why? Because that number is already positive, okay? So subtract 6x and subtract 7. Okay, so to maintain the positive coefficient for x squared, we subtract 6x and 7 instead of subtracting 2x squared, okay? So from here, you can see that A is 2, B is negative 6, and C is negative 7, right? Okay, so what's the discriminant? D is equal to B squared minus 4 times A times C. Okay, so now negative 6 squared, what's that? 36, right? And now that is what? So 4 times 2 times 7 is what? 56? Is it minus 56 or plus 56?
Is it plus and minus?
There's no plus minus. There has to be a 1 sign. There's no plus minus here because that's not a quadratic formula.
It's plus.
It's plus. Do you see why? It's minus and then negative, so they become plus, right? Yeah, so it's plus 56. Okay, so what is this? 92?
Yes, sir.
Okay, so that's the discriminant. Okay, so now we have a positive discriminant. So in quadratic formula, we will have square root of 92. Okay, so now the question is what? Can we remove this square root of 92 in the quadratic formula, not the discriminant, or we can't? You know, so in other words, is 92 perfect square or not a perfect square?
It's not.
It's not, right? Yeah, okay. So we have two distinct irrational. Okay, and again, the reason is that's not a perfect square. Okay. However, if this were like 100, then we'll have two distinct rational, okay? Because 100 is a perfect square. Okay, so any questions on these applications? Okay, so can I go to the next page? Okay, so now let me jump to the chapter 2. Okay, so we will cover section 2.1 and 2.2, and then we will come back to chapter 1 and then finish it off. Okay, so 2.1 is about graphs and two formulas. Now, this section is optional. Okay, so optional means it won't be covered on any exams. Okay. However, we still have to cover this because the graphs that will appear in this section will be covered multiple times throughout this course. And also the two formulas, which is right here in this box, will be covered in the next section 2.2. Okay, so just keep in mind that this section 2.1 is not part of any exams. But still, it's important for you to understand the future materials. Okay, so here are the two formulas. So the first one is the midpoint formula. Okay, so let's start with the one-dimensional case, which means the number line. Okay, so there are two numbers, 3 and 7, on the number line. What's the midpoint of these two?
5.
Okay, now, how did you get 5?
Because it's
Yeah.
halfway between the two numbers.
Right, so how can you produce 5 using 3 and 7? So 5 is what? Add the two ends and divide it by 2, right? Okay, now extend our concept to xy plane, okay, which means two-dimensional, okay, so the cross plane here. So now it's similar. So the midpoint, now the label of this midpoint is capital letter M, okay, so that's the label of the line segment PQ, okay, so PQ is the label of this line, the line segment. Between the 2 points, x1, y1, and x2, y2. Okay, so now we have P and Q in front of x1, y1, and x2, y2. Does that mean we are multiplying the letter P to x1, y1, and Q to x2 and y2? No, that's not the multiplication, okay? That's just the label. Okay, so the label of the first point is P, but still, we use P in front of that x1, y1, and then the label of the second point Q, x2, y2, we still write it like this. Okay, so P and Q are just the labels of the 2 points. Is equal to, okay, so here we add the x coordinates and divide it by 2, and do the same thing for the y coordinates. And since it's the points on xy plane, we put them in an ordered pair. Okay. Now, that's the midpoint formula. The distance formula. Okay, so now the distance formula. So still, let's look at the one-dimensional case, 3 and 7 on the number line. What's the distance between these 2 points?
4.
4. Okay, and how do you get 4 using the two numbers 7 and 3? You subtract.
7
right?
minus 3.
Yeah, 7 minus 3, right? Okay, so now when we extend this concept to xy plane, it's similar, but also it's somewhat different. Okay, and here is the midpoint or the distance formula. So the distance and the label of this distance formula or the distance is d parenthesis p comma q. Okay, again, we are not multiplying d to p and q, like we are not distributing d, but that's just the label of the distance. Between the 2 points, p and q, x1, y1, and x2, y2, is given by, okay, So we write, d equals in front. And then look this formula closely. So what do you have to do? Subtract the x coordinates and then subtract the y coordinates, but that's not it, okay? You need to square it. Same thing for the y coordinates. And then you have to add them and then take the square root outside. Okay, so it's kind of weird. But the reason is, you don't have to know its reason, but when you have 2 points, x1, y1, and x2, y2 like this, to get the distance here, so what people do is they consider this right triangle, okay? And hopefully you remember some kind of famous formula about the right triangle. Remember this? A squared plus b squared equals c squared. Okay, so here what do? When you take the square root both sides, you get c is equal to a squared, square root of a squared plus b squared. Okay, and notice that this one is very similar with this. Okay, now that's the reason, but you don't have to know why such formula looks fairly weird like this. Okay, but that's the reason. Now, let's do a problem which will use these two formulas. For the given points P and Q, find the distance and the midpoint. Okay, now, no matter which formula you use, what do you need? X1, X2, Y1, and Y2, right? Okay. So what do you have to do? Identify those coordinates, X1, X2, and Y1 and Y2. So here, let's see, what is X1? So that can be X1, right? Okay. And Y1 is equal to 3. Okay. And then that's X2 and that's Y2, right? Make sense? Okay, so now let's do the easier thing first, the midpoint. Okay, so the midpoint first. So how do you get the midpoint, remember? So first you add x coordinates and divide it by 2. And do the same thing for the y coordinates, right? Okay, so what does that mean? -4 plus 2 all over 2. Okay, and then 3 plus -5 all over 2. Okay, and these two are what? Coordinates, right? Coordinates of a point. So put them in an order pair like this. Okay, and now simplify. What is -4 plus 2 all over 2?
1.
Be careful.
-1.
-1. And now, what is 3 plus -5 all over 2?
-1.
Also -1, right? Yes. Okay, -2 over 2. So -1, comma 1 or -1 is the midpoint m. Okay. Now, the distance. So the distance, so what do we do? Subtract x coordinates and subtract y coordinates, right? Okay, but we first have the square root outside, okay? So what do we have? -4 minus 2 squared. And then plus 3. Okay, so now we do y1 minus y2. Now, is it 3 minus 5 or 3 plus 5?
Plus.
Plus, do you see why? Okay, it's 3 minus -5, right? Okay, so it's not 3 plus or like 3 minus 5, right? It's 3 plus 5. Okay, so what is this? That's negative 6 squared. So that's what, 36, right? Okay, and then 8 squared. So that's what, 64, right? Okay, so 36 plus 64, that's what, 100? Okay, so we have square root of 100. Can we simplify this further? What is square root of 100?
10.
10, right? Yes. Okay, so 10 is the distance between these two formulas. Okay, can I go to the next page? Yep. Okay, so now part B. 6 comma negative 2 is P and 4 comma 6 is Q. Okay, so again, let's identify x1, oops, y1 and x2, y2. Okay, so first thing first, the midpoint. Okay, so the midpoint, remember, what do? Add x coordinates and you divide it by 2, right? Okay, and then add y coordinates and then you divide it by 2 and put them inside an ordered pair, right? Okay, so now what is 6 plus 4 over 2?
5.
5. And what is negative 2 plus 6 all over 2?
2.
2. Do you see why? 4 over 2, right? Okay, so that is the midpoint M. And now the distance. Okay, so first we have the square root here. And then remember it's x1 minus x2 squared. So what does that mean? 6 minus 4 squared, right? Okay, and then y1 minus y2, so that's negative 2 minus 6, and then squared, right? Okay, so now simplify. So that's 2 squared, so that means 4, right? And then plus negative 2 minus 6 is negative 8, and then you square it. So what does that mean? 64, right? Okay, so we have square root of 68. Can we simplify this or are we done?
We're done. No?
Okay,
You want
so
us to do the
that's not a
factor
whole
tree?
number. Okay, yeah, that's not a whole number, but still we can simplify this, right? Yeah, okay. So now simplify square root of 68. Okay, so how do we simplify? Yeah, that factor tree thing, right? So 68 is what times what?
2 and 34.
Okay, 2 and 34. And 34 is what times what?
Two and 17.
2 and 17, yes. Okay, and now we are stuck, right? Because 17 is prime. Okay, so what do we pull out? The 2, right? Anything left over?
17.
Right? So 2 square root of 17 is the answer. Okay, so even if your distance at the end is not a whole number, you still have to see whether you can simplify the square root. Okay? Any questions from these distance formula and midpoint formula problems? Okay, so these are not that hard. So now, this is the first half of 2.1, and I will go to 2.2, and then once we finish 2.2, I will come back to 2.1 and finish the rest of it, okay? So let's go to 2.2. Okay, so here is 2.2. The circles. Okay, so circles, that is kind of like one of the most interesting objects in math, okay? And any circle has two components, okay? Any circle has two components. What are some components of the circle that you can think of? So basically, what does any circle have?
A radius and a diameter.
Okay, okay, the radius, yes. Okay, now the diameter is not a component because you can get diameter from the radius. But there is a special point for any circle.
Center.
The center?
Center, yes. Okay, so those are the two components of any circle. And that leads to the following, okay? So there are two representations of a circle. So here representation means formula, okay? And maybe you didn't know that there are formulas for a circle, but there is, okay? And the first one is called the center radius form. Okay, so now, what does it say? The equation of a circle with center h comma k. Okay, so now, like I said before, center is a point, and this circle will be on xy plane, so it has ordered pair h comma k. Okay, and the radius, and now radius is a number, right? It's a value. Okay, so let me use the lowercase r, okay, for the radius. Is given by x minus h squared plus y minus k squared is equal to r squared. Okay, so that is the center radius form of the circle. Okay, so now before we go to the general form, I want to deduce three remarks. Number one, let's look at the right-hand side, r squared. Is this the diameter? No, right? Do you see why? Okay, so here, let me draw some sample circle, okay, right here, okay? So here's the center and here's the radius, right? Well, what's the diameter? So that's the diameter, right? Okay, and what does that mean? Here is another r. So what's the diameter? It's not r times r, right? Rather, what's that equal to? Yeah, r plus r, right? So what does that mean? It's 2r, right? Okay, so again, that's not the diameter. It's not the diameter. Rather, the diameter is equal to 2r, right? Okay, r plus r. But this one is r times r, right? Okay, so that's not the diameter. And now, second remark. You subtract h and k from x and y respectively, okay? So that subtraction is the basic form. Okay, the reason I'm saying this is because later when you see something like x plus 2 squared or even like y plus 3 squared, you need to be able to correctly identify what should h be equal to and k should be, or k, like what k should be. Okay, so for example, here h is -2 and k is equal to -3. Okay, it's not 2 and 3. Okay, so that's the basic form of the center radius form. Okay, and now the last remark. X minus h squared and y minus k squared. So for example, when you have something like x minus 2 squared, so this is same thing as x minus 2 times x minus 2, right? Which you can FOIL. But the problem is, do you FOIL these two products? And the answer is not for the center radius, okay? So for these two, you should not FOIL for the center radius form, okay? You don't FOIL at all. You just leave it as it is, okay? Does that mean we cannot FOIL these two products? Oh, yes, we can, okay? We will be able to FOIL it, but that leads to something else, the general form, okay? So how do you get the general form? You get the general form from the center radius. If you FOIL the left-hand side and simplify, we get something like this. Okay, so what does that mean? So here simplify means what? So first we have to have 0 on the right-hand side. So we move our square, right? Okay, that's the first thing we do. Okay, so we subtract our squared. And then if you look this left-hand side closely, what do you notice? The squares are written first, and then the non-squares come, and then the pure number comes at the end, right? Okay, so we rearrange the terms. Okay, that's what I mean by simplify. So that the squares come first, and then the non-squares come second, and then the pure number comes at the end. Okay, and then 0 on the right-hand side. Okay, so that's how we get the general form from the center radius. Okay, so now for the circle, what you can do is you can sketch the graph. However, you cannot sketch the graph in a normal way, like you draw the graph of any other shapes. So how do you graph a circle? First, you need to come up with 2 points, okay? One of them is fairly easy, plot the center. Okay, and then step number 2, find the second point. Now, how do you find the second point? It has to lie on the same horizon as the center. So what does that mean? For example, here is the center on a circle, okay? And same horizon means what? Either this or this, right? Okay, so in other words, these 2 points are the 2 ends of the diameter, okay? So that's how you get the second point, which lies on the same horizon as the center, okay? Okay, so this circle, especially the center radius form, is not fairly easy, so let's practice these formulas onto the problems, okay? So find the center radius form of each circle and then graph it, except for part C, which is on the next page. You'll see why. Okay, so find the center radius form. Okay, so that means we have to look at this first one. Okay, x minus h squared plus y minus k squared equals r squared. Okay, so now for this center radius form, how many unknowns do we have?
Two.
Say it again.
2.
2, because of x and y? No, x and y are actually not unknowns.
H and K.
H and k and one more,
R.
R as well, yes. Okay, so here, first of all, X and Y are not the unknowns. They will be part of our answers. But here, rather, the unknowns are H, K, and R. Okay, so what do we have to do? So here, we need to identify H, K, and R. Okay, now, is R easy to identify? Yes. Do you see what R should be? 3. Why? Because R is the radius, right? Okay, now, what should H and K be? So H and K come from what? That's the X and Y coordinates of the center, right? Okay, so from here, can you see what H should be?
1,
1, yes. And K is? Negative 2.
negative
right?
2.
Yeah, negative 2, right? Okay, so now what do you have to do? Plug them in. Plug these into the center radius form. Okay, so now let me use CR for the center radius form. Okay, so what do you have? X minus H, which is 1 squared, and then plus Y minus K. Okay, so that means what? Y minus 2 or Y minus negative 2?
Minus.
Minus 2?
Yeah. Didn't you say it always negative?
Well, it has to have the negative sign as part of the center radius form, but what about here?
So it'd be plus 2.
Right? Because it's Y minus negative 2 squared, right? Okay, is equal to R squared, which is 3 squared. Okay, so how can you rewrite this? So it's X minus 1 squared plus Y plus 2 squared, and then 3 squared is 9, right? Okay, and remember, you are not foiling the two products on the left for the center radius form. So what does that mean? You stop right here. Okay, so again, no FOIL for these two. Okay, that's it for the center radius form. Okay, so the best thing that you can do is put minus and negative into plus, and then evaluate the right-hand side. That's all. Okay, that's it. You are not foiling the right-hand side or the left-hand side. Okay, so now graph. Okay, so remember, to get the graph, you have to plot the center first, and then find the second point which lies on the diameter. Okay, so the center is at 1, negative 2. Okay, so 1, negative 2. 1, negative 2. So it's in the 4th quadrant, right? Okay, and now, how can you get the second point, which has to lie on the same horizon? So same horizon, remember, means on the diameter. So what do you have to use from the center?
Negative 2.
Right, so here you have to use one of the two values, 1 or negative 2, and the radius, right? Okay, that's how you get the point which lies on the same horizon. So let's say you go to the right, okay? From 1, negative 2, you go right by 3 units. Where are you? Which is this point. What's the coordinate of this point?
4, negative 2.
4, negative 2, right? Okay, because we add 3 to 1 only. Okay, negative 2 doesn't change. Now, can you go to the left like this by 3 units? Oh yeah, it's fine. Then where are you? Negative 2, right? Because you subtract 3 from 1. Okay, but of course you can go up or down like this. So let's see, how does the circle look like? whatever, something like this, right? Okay. The toughest object in math to draw precisely is the circle. Okay. Yeah, there will be like the egg shape or the oval shape or some kind of bizarre circle, like whatever. But anyways, when you do your homework, you'll be able to get the precise and nice and smooth shape of the circle, but not here. I'm not a computer. Okay, so that's that. And part B. The center is at 3, 0, and the radius is 4. Okay. So again, we do the same thing, identify H, K, and R. Okay, so I guess the radius is really automatic, right? So the radius is 4. Okay, and what is H?
3.
3, right? And K is equal to 0.
0.
Yeah, right? Okay, so now plug them in to the center radius form. So what do you get? X minus H, which is 3 squared, plus Y minus K, which is 0 squared, is equal to 4 squared, right? Okay, so now here, there is no minus and negative sign, so there won't be any plus sign inside parentheses, but can we rewrite something? What is Y minus 0 squared equal to?
Y squared.
Just Y squared, right? Yes. Is equal to 16, okay? And again, we are not foiling this for the center radius. So that's the answer. Okay. So now let's sketch the graph. Okay, so the center is at 3, 0. Okay, so the center is at 3, 0. So what does that mean? It will be on the x-axis right here. Okay, now get the second point. Okay, so let's see. Let's say you chose to go to the right by 4 units. Okay. What is this point equal to?
7.
7, 0, right? Yes. Okay. Now, if you choose to go to the left by 4 units, then this point is what? Negative 1, 0, right? Okay. So, how does the circle look like? Your circle looks something like this. Ooh, okay. There we go, whatever. Okay, so it's kind of big circle. Okay, can I go to the next page? Yeah, okay. So now, remember for part C, you don't have to sketch the graph, and hopefully you can see why. So now what's the issue here? The square roots, right? Okay, but I didn't say that the center and radius cannot have square roots, like they could have square roots, so this is fine, okay? But the graphing is kind of bizarre here, so that's why we are not gonna sketch the graph. Okay, so the first step remains the same, identify H, K, and R. Okay, so the R is fairly automatic. It's square root of 11, right? And then H is what? Square root of 3. K is square root of 5, right? Okay, so now plug them into the formula. So what do you get? X minus H, which is square root of 3 squared. And then plus Y minus K, which is square root of 5 squared, is equal to R squared, square root of 11 squared. Okay. So now, this is equal to x minus square root of 3 squared plus y minus square root of 5 squared. Now, what is square root of 11 squared?
11.
Just 11, right? Yeah, okay. And now, can we simplify these two products? So in other words, is this equal to like x squared minus 3? Or even this is like y squared minus 5? Is that true? No, right? And remember, like this is false, first of all. And remember, you are not foiling these two for the center radius. So that is the best thing and the farthest point that you can go. Okay, that's it. Okay, that's it. Okay. So here we could only simplify the number on the right, and that was it. Okay, so now, any questions on this center radius form?
If one of those was a perfect square, would you simplify it?
Yes, but that wouldn't be the case because like if this were like square root of 4, then people would write just 2. Yeah, so it like this is just too mean. Like so like none of those will be perfect squares.
Okay.
Yeah, yeah. Okay, so now the next box. Have we seen these two formulas before? Yeah, like 10 minutes ago, right? Okay, so the midpoint and the distance, here they come once again. Okay, so since we have mentioned these two statements, I'm not going to repeat them, but you might wonder why are they appearing here once again? The midpoint. We will use this midpoint formula to find what? So there is a special point for any circle, which is what?
Center.
The center, yes. Okay, and now what about the distance? Well, there is a special distance for any circle, and what's that distance called?
Radius.
The radius, yes. Okay, so now let's use these two formulas on the following problem. Okay, using the circle below, find the equation of the circle in part A, center radius form. Okay, so I guess you can guess what part B should be, okay, which the form that we haven't touched yet, the general form. Okay, so now, center radius. Center radius, what do we need? Center and radius, right? Obvious, duh, okay. So to find the center radius form, we need center and radius. Okay, so that's automatic. So we need center and radius. Need center and radius. Okay, now look at the graph here. So where seems to be the center? Right here, right? Okay, now this graph is just so perfectly given that you can even easily guess what the center is. But let's pretend that we don't know about anything about these points here, okay? So we have to somehow manually get the center, okay? So what does that mean? What do we have to do? Use this formula, right? Okay, so now, how do we find the center? So first, we need to have the 2 points, and that will be, or the center will be the midpoint of the such 2 points. Okay, so now what does that mean? What does that mean? So here is the center, and we can consider like this line segment, or maybe this line segment, right? And now, is the center the midpoint of the 2 points? Okay, now which 2 points? So in other words, the center is the midpoint of which 2 points?
They have to be in the same horizon.
Right? Either these 2 or these 2, right? Can we choose like these 2 points? No, right? Because the midpoint of these 2 points is somewhere here, but that's not a center, right? Okay, so it has to be either these 2 or these 2 and nothing else, right? Okay,
Right.
so which 2 pair or which 2 points do you want to choose? These 2 or these 2?
Let's do the -4, -2, 2, -2.
Okay, so the midpoint between -4, -2, and 2, -2. Okay, so what does that mean? That's like x1, y1, and x2, y2, right? Okay, because we need to identify the coordinates. Okay, so this is equal to what? So -4 plus 2 all over 2, comma, -2 plus -2 all over 2. Okay, and then put them inside order pair. So now, what is -4 plus 2 all over 2?
Hold on, I thought it was negative. Oh, never mind. I see.
Yeah,
Sorry,
yeah,
go
right.
ahead.
So yeah, because we
I'm
need
with
to
you.
add, yeah, we need to add the x coordinates, right? Okay, so what is -4 plus 2 all over 2?
1.
Mm,
-1.
thank you, -1. And -2 plus -2 all over 2.
-2.
That's -2, right? Okay, so the center is at, whoops, -1 comma -2. Okay, so now step number 3, find the radius. Okay, so now how do you find the radius? So from the picture here, all of these are radii, right? Okay, so what is the radius? So to find the radius, we use the distance formula, right? And it's the distance between some 2 points, okay? So the radius is the distance between which 2 points?
The center and one of the outside points.
Do you see that? Okay, so the center and either of these 4 points, right? Okay, so this one is the distance between the center, -1, -2, and which outside points do you want to choose?
2, -2.
2, -2, okay. And remember, it doesn't matter which point you choose, right? You can choose -1, 1 or -1, -5, either way, okay? So what does that mean? Now we need to newly identify x1, y1, and x2, y2. So this is equal to square root of x1 minus x2, so that's -1 minus 2 squared, and then plus y1, which is -2, okay, and then be careful, it's minus and then -2 squared, right? It's not -2 minus 2 squared, it's -2 minus -2 squared, okay? So that's -3 squared, so that's 9, right? And then what is -2 minus -2 squared? What's that equal to?
Is it 16?
Be careful. -2 minus -2.
0.
0, yes. Negative 2 plus 2, right? So they just cancel. So square root of 9 plus 0, so that's just square root of 9, right? Which is equal to 3. Okay? So now, do we have all the ingredients? Yes, we do. Okay, so now the center radius form. Okay, so the center radius form, remember, we need h, k, and r. Okay, so what is h? The x coordinate of the center, so that's negative 1, right? And what is k? That's negative 2. And 3 is r, right? Okay, so h is negative 1, k is negative 2, and r is equal to 3. So plug them in to the formula. So what do we get? X and then minus, now is it x minus 1 or plus 1?
Plus.
Plus, right? Yeah, because it's x minus negative 1 squared, okay? And then similarly, y minus negative 2 squared, and then is equal to 3 squared. So we get x plus 1 squared plus y plus 2 squared is equal to 9. And remember, we are not foiling the first two products, okay? So that is the center radius form. Now, part B on the next page is about the general form. Okay, can I go to the next page? Okay, so now, the general form. So remember, how do you get the general form? So going back to the very first page, you get the general form by foiling this time, finally, the left two products, okay? And remember, we need to make one side equal to 0, and then we need to rearrange so that the squares come first and then so on, okay, in descending powers. Okay, so let's copy the center radius form. So it was x plus 1 squared plus y plus 2 squared is equal to 9. Okay, so now what do we have to do? FOIL, right? Okay, so now FOIL x plus 1 squared. What do you get? Is it x squared plus 1? When you FOIL this, do you get x squared plus 1? No, right? What do you get? X squared. And then what's next? So when you combine the two middle terms, what do you get?
X squared plus x plus 1.
Oh, not x. There's something in front of x.
2x.
2x, right? Yeah, plus x plus x plus 1, right? Yeah, okay, so plus 2x plus 1. Okay, and now for this, y plus 2 squared. So it's y squared, and then plus 2y plus 2y plus 4, right? Okay, so what do you get? Plus 4y plus 4, right? And that's equal to 9. Okay, so now that's not the end, so we need to rearrange, right? So rearrange. Okay, and you know, move 9 or subtract 9, okay, as well. So you subtract 9 from here, and then rearrange so that what? The squares come first, and then the non-squares come second, right? Plus 2x plus 4y. And now the numbers, 1 plus 4 minus 9. That becomes what? Minus 4 is equal to 0, right? Okay, so that is the general form. Okay, so any questions from this previous problem? Okay, so now it's not hard to go from the center radius or from center radius to general form because we just have to follow and rearrange. But can we go backwards? That is from general to center radius, and the answer is why not? Okay, so how do we go back? Complete the squares for x and y. Have we seen this completing the squares before? Yeah, just yesterday, right? When we were solving quadratic equations, okay? So, before we do the next three problems, let's fill in the blank for this important fact, okay? So the relationship between x minus h squared plus y minus k squared equals c. Okay, now, it seems like this is the center radius form, but I claim that it's not the center radius form. Why? What's the difference between the actual center radius form and this?
Class number is it?
Say it again?
Because this says it equals C and not R.
Right? So the right-hand side is not r squared, it's just c, right? Okay, so this c is some number. Okay, so that's why it's not the center radius. Okay, so there are three cases. Positive c, okay? If that's the case, then the graph is a circle, okay? With the center, HK, and now, what's the radius? The radius is not equal to C, okay? Because, you know, actual center radius form had r squared here, so how do you get the radius? You need to square root it, right? Okay, so the radius is equal to square root of C. Okay, it's not equal to C, you need to take the square root, right, to get the radius. Okay, so when the C is positive, the graph is a circle. Now, if C is equal to 0, okay, so now that's equal to 0. So like, for example, you have something like this, okay? Now, this thing, you are squaring something, and same thing for this. And whenever you are squaring any number, what's the sign? It's always positive, right? But there's only one case where it becomes a 0. And what's the case? That, right? When you square a 0, you get a 0, but everything else becomes positive. So what does that mean? That guy has to be 0. That guy has to be a 0. So what do you get? X is equal to 2 and y is equal to 3, right? And, oh, what does that mean? The graph is a single point. And what's the coordinate of this point? 2 comma, I'm sorry, h comma k. Yeah, 2 comma 3 was just an example. H comma k. Okay, so what does that mean? It's not a circle, but you can think of it as a circle with like 0 radius, like that. Okay, but the graph is a single point. And now, the value is negative. So you have x minus 2 squared plus y minus 3 squared is something like -2. Okay, now you are adding the two positive numbers. So how can you get the negative number at the end? Is it even possible? No. So what does that mean? there is no graph. It's just impossible case, basically, okay? So you have to have this x minus h squared plus y minus k squared, and then after that you can deduce what that c should be, and then you can identify what kind of graph you should have, okay? So now, let's look at this following problem. So this is the main problem of this section, the circle. For each equation, determine whether or not the graph is a circle. If it is, find the center and the radius. If not, describe the graph. Okay? So now, here is C, okay, which is on the number on the right side, is C equal to 44?
Yes, C is 44.
No, it's not.
Oh,
Sorry. Now, why? Why not?
It's not in the right form.
It's not in the right form, yes. Okay? Because when you look at the left-hand side, what do you have to have? Some kind of squares, right? Like some chunk square plus some chunk square. Do you have some chunk square here on the left? No. Okay? So that's not equal to C. Okay? So again, it's not a C. Okay? So what do you first have to do? Express it something like this. And what's that process called? Complete the squares. Okay? So step number 1, you have to complete the squares for x. Okay? So now, how do you complete the squares for x? Okay? So the scheme is, we will first ignore all the y's, okay, for now. For now, we will ignore all the y's. So what does that mean? Let's look at x squared plus 4x is equal to 44. Okay, now, we just learned this yesterday. Do you remember what the scheme is for completing the squares? Do you remember what the scheme was? Okay, so here is the page. So what do you have to do? First, you send all pure numbers to one side. Remember that? And then you have to take the coefficient of x, divide it by 2, and then square it, and then you add it to each side, and then you factor the left-hand side, and then so on. Remember that? Okay, we just learned this yesterday, but since we are learning too many things in a short period of time. Okay, so now, from here, do we send the pure number, which is 44, to the left-hand side, or do we just leave it like that? So in other words, do we subtract 44 or we don't?
You leave it there.
Right, we don't subtract, okay? Because the number is already on the right-hand side, okay? And now, what do? Take the coefficient of x, divide it by 2, and then square it. And what's this number equal to? 4, right? 2 squared. And now what do? You add it to each side. So x squared plus 4x plus 4 is equal to 44 plus 4, right? Okay? And now, what do we do with this? X squared plus 4x plus 4. Do we do something? Okay, we need to factor, right? Okay, so now can we factor this x squared plus 4x plus 4? And if so, what do you get when you factor?
Two and two.
Right? So what does that mean? X plus 2 times itself, right? Or x plus 2 squared is equal to 48, right? Okay. Now, here, since we are not solving for x, let's stop here, okay? We don't have to go any further than that. So we have completed squares for x. And now, complete the squares for y. But before that, what do we have? So now, instead of x squared plus 4x plus 4x, or x squared plus 4x, we have x plus 2 squared, okay? And then put y's back in, y squared minus 8y. And now, the right-hand side is no longer 44, right? Because we have changed that to 48, okay? So we have equals 48. And now, complete the squares for y. Okay, so now what does that mean? We do the same thing, so now we ignore x. Okay, so what does that mean? Don't look at this for now. Just look at this part. Okay, so what do we do? Do we move 48 to the left-hand side or no? No, right? So we take the coefficient of y, which is -8, divide it by 2, and then square it. So what is this? Positive 16, right? Okay, and then you add this to each side. So what do you get? Y squared minus 8y plus 16 is equal to 48 plus 16. Okay, and now, can you factor this left-hand side? And if so, what do you get when you factor?
X minus 4 squared.
Right? So it's y minus 4 times itself, right? Okay, so it's y minus 4 squared is equal to 64. Okay, so now put everything together. So what do we have? X plus 2 squared, and then plus y minus 4 squared is equal to 64. Okay, and now we have completed squares for x and y, and now can you see what the value of c is? What's the value of c here? 64, right? Okay, so now this is the value of c. Okay, because we have completed squares for x and y. So now, is this a circle? Yes, and what's the reason? That 64 is positive, okay? So, since 64 is positive, it's a circle, okay? Oops, since. So, what is the center? Where is the center of this circle? Okay, so again, we have to use what? H and K, right? So we have to identify H and K. what is h here?
H would be -2.
-2, yes. Do you see why it's not 2? Okay, because remember, that is plus sign, so it's x minus -2, right? Okay, so h is -2, and is c -4 or +4?
It'd be +4.
+4, right? Yes. Okay, be careful. So many people say 2 comma -4 is the center, but it's the opposite. And what's the radius? Is it 64? No. It's instead what? That, right? Which is equal to 8. Okay, so that's the center and the radius. Okay, can I go to the next page? Okay, so now, part B, x squared plus y squared minus 6x plus 2y plus 12 is equal to 0. Okay, so again, here, be careful, c is not equal to 0, right? Okay, because the left-hand side is not in a completed squares form. Okay, so what do we first do? Complete squares for x. Okay, so what does that mean? We focus on the x's, x squared minus 6x plus 12 equals 0. Okay, that's what we focus on. And now, do we need to move the 12 to the right-hand side or no? Yes, we should, right? Because we need to, we don't want to make one side equal 0. So x squared minus 6x is equal to -12. And then what do? Divide the coefficient of x by 2 and then square it. So what is this number? +9, right? Okay, and then you add it to each side. So x squared minus 6x plus 9, and then -12 plus 9. And now, can you factor the left-hand side? And if so, what do you get?
X minus 3 squared.
Right? So x minus 3 squared. And now, we have, at this point, x minus 3 squared plus y squared plus 2y. And now, be careful, plus 12 is gone, right? Because we have changed that to -3, so it's equal to -3. And now we complete the squares for y. Okay, so that means we look at this part, right? Okay, and here we don't need to move -3 to the left, so leave -3 as it is. And then what do? Divide 2 by 2 and then square it. And that's equal to 1, right? So what do? X minus 3 squared plus y squared plus 2y plus 1 is equal to -3 plus 1. And now, can you factor this? Y squared plus 2y plus 1. And what do you get? Y plus 1 squared, right? You see that? Okay, and the other side is what? -2, right? Okay, so we have completed squares for x and y. And now, what is the value of c on this case?
Negative.
Negative 2, right? Yes. Okay, so that's the value of C, right? Okay, so, which is negative. So, is this a circle? No. What kind of graph do we have here? What kind of graph do we have?
You can't graph it, it's impossible.
Right? No graph. Okay, because C is negative. Okay. And now, the last part, C. X squared plus y squared minus 6x minus 6y plus 18 is equal to 0. Okay, so now, again, we will look at the x part. Okay, complete the squares for x. So now, what does that mean? We have to focus on x squared minus 6x plus 18 equals 0. Okay, so now, here, I will skip a step. So what do? First, we subtract 18, right? Okay, and then we do negative 6 over 2 squared, and that's equal to positive 9, right? And we add it to each side. So what do we get? X squared minus 6x plus 9, and is equal to negative 18 plus 9, right? And what is that? Negative 9, right? You see that? Okay, and the left-hand side can be factored into what? X minus 3 squared is equal to negative 9. Does it make sense? Okay, and now, look at the y part. Okay, so now, for here, what do? X minus 3 squared plus y squared minus 6y is equal to negative 9. So that's where we start from, right? And then we look at this. So negative 6 over 2 squared, that's equal to positive 9. And then we add it to each side. So what do you get? X minus 3 squared plus y squared minus 6y plus 9 is equal to negative 9 plus 9, 0, right? And then factor this. So x minus 3 squared plus y minus 3 squared is equal to 0. Okay, so we have completed squares for x and y. What's the value of C on this case?
0.
0, right? That's the value of C. So what kind of graph do we have? The
Single
graph
point.
is a single point, and that's so-called the fake center, right? Still H and K, but it's the fake center. So what point is it? What's the coordinate of this point?
Give me 0.33.
3, yes. Do you see why? That would be the center of this circle, right? If this were a circle, okay, that would be the center, right? Okay, so that is the graph. So on XY plane, here is 3, and that's the graph. That's all. Okay, so it's the circle with like 0 radius, basically. Okay. Okay, any questions on this completing the squares problem? Okay, so like I said, this is the main problem of this section 2.2, so it's really important for you to get used to this completing the squares. Okay, so please practice. Okay, so now let's go back to 2.1 and wrap up the second half of 2.1. Okay, so where was it? Okay, there we go. So the next thing that we will study in 2.1 is the library of basic graphs. Okay, so some of you may already know these graphs, but some of you may not. Okay, or maybe you just forgot. Okay, but these graphs will appear like 1,000 times in the future, so we will revisit many, many times. Okay, so the graphs are on the next page, right here. The library of basic graphs. Okay, and hopefully you remember or already know some of these graphs from the past math course. So y equals mx plus b. Have you seen this form before? Yeah, you should. How does the graph look like?
Slope intercept.
Okay, so slope intercept. So slope and intercept come from what kind of graph? How does the graph look like? Like when you draw the graph on XY plane?
Perpendicular.
Okay, yeah, but like graph. There is a specific shape of the graph. Slope intercept form comes from which graph? Hint, that is a linear form. So the word linear comes from which graph? What kind of graph? Linear.
Is it a line?
Line, yes. Okay, right? So now line can have 4 representations. One is this. Okay. Can it go the other way? Yes. Okay. Now, can it look like this? Yeah. Okay. Now, there is another way of drawing the graph of a line, but that's not part of this first form, and I'll tell you why in a minute. Now, what about this? Ax plus by equals c. So, for example, you have something like 2x plus 3y equals 4. Have you seen this kind of representation before? Okay, so here, what can you do? Maybe subtract 2x, okay, like 3y equals negative 2x plus 4, divide everything by 3. So eventually, where are you? Like, where do you end up with? This, right? Okay, so what does that mean? The graph is also a line. And now, finally, we have this vertical line case. Okay, now, why is the vertical line not part of this mx plus b? Because if you remember from your past math class, the vertical line has the representation x equals some number. Remember that? Okay, so in other words, there is no y. So here, if you take b to be 0, then you have x equals whatever, so you have this vertical line. But what about here? Y has to be present, right? You cannot remove y. Okay, so that's why the vertical line is not part of this mx plus b. Okay, and now the next one, y equals x squared. Have you seen this graph before? Y equals x squared. How does the graph look like? Right, it's the parabola, right? Yes. Okay, parabola. And we will study this parabola in detail in chapter 3. And now things become a bit tricky. Square root of x. Has anyone seen the graph of square root of x before?
Isn't it like an S shape or like?
S? That's this. Okay, yeah. So here the graph is this. Now, what about square root? That's absolute value, Rhonda. That's absolute value. Okay. The V shape is absolute value. Now, for square root, there is only one curve. Have you seen this uphill graph? Does it look familiar? Okay, yeah, some people say this is like uphill, and some people say x cubed graph is like a snake, which, okay, I get that, but I don't like snake, so anyways. So it's a snake, and then that's like the V shape. Okay, so we will see these graphs like many times in the future. Anyways. Okay, so now, knowing these graphs is not enough, unfortunately. What you have to know is, how do we get these graphs? Okay, how do we get these graphs by hand? So can I go to the next page? Okay, so now, to graph any equation, okay, so hopefully you have seen this scheme before. So to graph any equation, what do you have to do? You have to plug in some small whole numbers to x, okay? Here I put x or y, but most people choose to plug in numbers to x until you get another whole number as the other coordinate. Now, what does that mean? So for example, this is an okay point, okay, this is fine. However, it's not okay for the MyLabs Plus. And for those who have used it before, you already know it, why this is not okay for MyLabs Plus, because XY plane on MyLabs Plus does not contain any fractions. I don't know why, but it is designed that way, okay? So just in case you get a fraction for either or both coordinates, you cannot use them even if they are right. Okay, that's just a characteristic of MLP. So that's why you have to keep plugging in numbers to x until you get another whole number for y. Okay, and get roughly 3 points. Okay, so again, this is not an okay point because it deals with fractions. Okay, so now let's do maybe 1 or 2 problems, and then that should be it for today. So for each equation, give a table with at least 3 ordered pairs that satisfy the equation and then graph it. Okay, so here the equation is -1/2 x plus 2 is equal to y. So here, the table with at least 3 ordered pairs, that simply means, have you seen the table with these 2 columns, x and y? Does it look familiar? Yeah, okay. So remember, y is -1/2 x plus 2. So let's plug in some small whole numbers to x until we don't get any fraction for y, okay? So what can we plug into x?
2.
2? Okay, so 2. So when x is 2, what's the value of y? Negative 1/2 times 2 plus 2, right? And what's that equal to? Negative 1 plus 2, so that's 1, right? Okay, so that's a good point. And now, can you plug in some more to x or y? So I guess you haven't chosen the easiest number, like the simplest number that's available.
1.
When, oh, well, there is even better number.
0.
Oh, 0.
Yes. Okay, so 0. So now, when you plug in 0, what do you get? Just 2, right? Okay, now plug in one more. Now, you said, some of you said 1. So what happens when x is 1? You get negative 1/2 plus 2, right? Is this a whole number? No, right? Because that's a fraction, right? So 1 is not a good number. So what do you want to do?
4.
4 to x, okay? So you have negative 1/2 times 4 plus 2. So what is this? That's negative 2 plus 2, right? Which is equal to 0. Okay, so in short, what is the ordered pair with the table? 2, 1, 0, 2, and 4, 0. Okay, now notice that each row here corresponds to the point, right? 2, 1, 0, 2, and 4, 0. So now, can we graph it? Yes, okay. So let's graph it. So 2, 1. So 2, 1 is here. Okay. And now 0, 2. Where is 0, 2? It's this point, right? And then 4, 0 would be somewhere here. Now, based on how these 3 points are lined up, can you see the shape of the graph? Yeah, it's this, right? Now, here's my question. Do we extend this graph beyond this point and beyond this point? Do we extend our line? Yes, okay. So extend it and extend it. And that's why sometimes people put these little arrows. Have you seen that before? Okay, to indicate that the line keeps going, right? Okay, so that's the graph. Okay, so we went like nearly 5 minutes over time, so I guess I should stop here. So, sorry about that. So tomorrow, so there are 4 more problems to go, so we will wrap up this section, which shouldn't take a long time. And then we will go back to chapter 1. And then, yeah, do 1.5 and 1.6. So let's see. I think what I'll do is, so yesterday one of you said when I'm gonna post the first extra credit homework, and we couldn't get to the section 1.5. So what I'm gonna do is I will wait until after class tomorrow to post that homework, and that homework will be due on Tuesday. Okay, so that's it for today, and I'll see you tomorrow at 10 o'clock.
Thank
Have a
you.
good rest of the day.
Thank you. You too.
You're welcome. Bye.